So dear student, now you can see the question on the screen. So question is related to strain energy. So here having a steel bar, so the total length of the bar is 1.5 meter. It means it's 1500 millimeter is the total length. Okay, let us say L is the total length, is of 50 millimeter diameter for a length of 900 millimeter. So one having a diameter of 50 with a length of 900 out of this 1500. So this is the length of 900 millimeter as the length, and 50 millimeter is the diameter out of the 1500 of its length. So again 25 millimeter diameter for the remainder. So for the remaining, it means for 1500 minus 900, so you are getting 600 is the remaining length. So from here the diameter is 25, it means half of this. If you take this as axis, so here half of this another diameter is 25. So this diameter is 25 millimeter is the diameter for the another remaining, and length will be 600 millimeter. Say this is a one element 1 and this is the element 2. Okay, and total length will be given as 1.5, it means 1500 millimeter is the total length of the given steel bar. Okay, so now you have to calculate what is the strain energy stored in the bar under a load of 45,000 Newton, and take the value of Young's modulus given as 2 into 10 power 5 Newton per millimeter square. Okay, so this is very clear. You need to find the strain energy now. Now let us start the solution. So all in the standard units, it means in millimeter, all the values are in millimeter and force is in the Newton. Now to calculate the area, first you should know what is the strain energy formula. Okay, strain energy stored in the bar. In the bar means total, both element 1 and element 2 you have to calculate. Okay, not individually. Okay, so let me know what is the storage energy in the bar, strain energy stored in the bar for a single element. The formula is where U is equal to sigma square A L by 2E is the formula for the strain energy stored in the bar. So now we are having two elements. So two elements means you have to add element 1 plus element 2. Okay, so assembling of element 1 and element 2, you are getting the total strain energy. It means where, let us say for this is for element 1, we will say U1, and here it will be sigma 1 and A1 L1 by 2E, and similarly same formula for U2 for element 2, sigma 2 square A2 L2 by 2E. So this is the for element 1, this is for the element 2. Now the total energy will be calculated like where U is equal to, it is U1 plus U2, that's it. Okay, u1 plus u2, total energy in the bar. So we will calculate the u1, where u1 is equal to 2 u1 is equal to sigma square. So to calculate the sigma, you have to first calculate sigma. Sigma is what? It is the stress in the element 1. So that is force per unit area A1. The force applied is, total force is 45,000. The load is applied by area for the element 1. For a bar it is pi by 4 d value is 50 square. So you have to calculate the stress first. Okay, then let me check to calculate the stress here. So I got 22.92 millimeter square, sorry, Newton per millimeter square. The stress unit will be Newton per millimeter square. Okay, similarly we'll go for calculating the sigma 2. Again F by A2, 45,000 by pi by 4, d value is here 25 square. Okay, now again if you substitute the force 45,000 by pi by 4 d square, the sigma 2 value will be 91.67 Newton per millimeter square. So this is sigma 1, this is sigma 2. So that only we have to calculate. Anyhow, area will be directly we are getting length and 2 by E, that you have to substitute at the end, where u is equal to if you make as 1 by sigma 1 square A1 L divided by 2E plus sigma 2 square A2 L2 by 2E. Now here we can make this 2E common. So it will be 1 by 2 into E value is given as 2 into 10 power of 5, 2 into 10 power of 5 Newton per millimeter square. Again in the bracket there will be sigma 1 square value, that is 22.92 square, again into the area for element 1. What is the area? We can, if you calculate the area separately, pi by 4 into 50 square, then it is 1963.5 into L1. L1 is for the element 1, it is 900. Okay, similarly this is for element 2. Now sigma 2 value we got 91.67 square into A2 value. Again if you make pi by 4 into d square, this one separately, if you make in the before only, then it will be easy for you. Sigma 1 sigma, and we have to make it A2 value 490.87 and L2 is 600. Okay, now all the value we have substituted, and finally we have to calculate the this total by 2 into 2 into 2 into 10 power of 5. Okay, so it's 8.5 8.5 so it's 8508 Newton millimeter. Okay, this is the strain energy stored in the entire bar. Okay, thank you.